Hey guys, welcome back to my channel, The Math Pad, and today we're going to continue with 2D Pythagoras and SOHCAHTOA, but we're going to practice some advanced questions. So if you look at the first one, it says the line AB represents the class walkway between the Pythagoras Towers in Kuala Lumpur. The walkway is 58.4 meters long and is 170 meters above the ground. The angle of elevation of the point P from A is 78.3 degrees. Calculate the height of P above the ground. Basically, they're asking us for PB. So they've given us the angle of elevation. They have given us the distance between A and B. And we have to find PB and then basically the entire distance of the ground. So what we do is, we remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. We draw a right angle triangle. If our base angle is, let's say, over here, this diagonal will always be the hypotenuse. The length opposite to the angle is going to be called the opposite, and the line on which the angle lies is called the adjacent. So keeping all of this information in mind, if you look at our diagram, we have the adjacent and we have the angle, but we need to find the opposite. So we'll use tangent. Tan 78.3 equals to PB over 58.4. Since the unknown is in the numerators, we cross multiply, find the value of PB. Now we just plug in the equation in the calculator. So it's going to be 58.4 tan 78.3, which gives us 282.00 meters. Now they're asking for the distance of P or the height of P above the ground. So this is where the ground is. Hence, the total distance is going to be, or the height is going to be 282.00 plus 170, which is going to give us 452.00. Yeah, because since it's asking us for the height of P above the ground, so we add the existing length as well. That's the next question. Question 2 says two circles with center O and C and radius 6 and 4 centimeters respectively touch at Q. PT is a tangent to both circles. Write down the distance of OC. So the radius is basically your distance from the center of the circle to the circumference. So if this length is 6 and represents the radius, OQ also represents the radius, which means this will also be 6. Any line that we draw from over here, this, all of these lines equal to 6 because they represent. Hence, OQ is equal to 6, and same goes for CT. So if CT is 4 and represents the radius, QC is also 4. Same logic. So OC is going to be 6 plus 4, which is 10 centimeters. Part B says calculate the distance PT. So for PT, okay. So we know that OC is 10. And if we connect this over here, if CT is 4, then this distance over here is also 4. And if entire OP is 6, which means this is 2. So if this is 2 and this is 10, why don't we use Pythagoras to find this horizontal distance? So it's going to be 10 square equals to 2 square plus x squared. That's 100 equals to 4 plus x squared. 100 minus 4 equals x squared. Square root of 96. So once again, put it in the calculator because it's not asking us to give the exact value. So that's going to be 9.8 centimeters. So since these two lengths are also equal, which means PT also equals to 9 centimeters. Question 3 is saying Mahmoud is working out the height h meters of a tower BT, which stands on a level ground. He measures the angle TAB as 25, which has been already marked. He cannot measure the distance AB, so he walks 80 meters from A to C, where angle ACB is 18 degrees and angle ABC is 90. So they're asking us to calculate the distance AB. So since it's a right angle triangle, 80 meters represents the hypotenuse of this triangle. And they want us to calculate AB. So AB is the opposite because the angle lies on BC. So what we're going to do is we have the hypotenuse, we have the angle, but we need to find opposites. So we use sine theta equals to opposite over hypotenuse. Sine 80 equals to AB over 80. Cross multiply to make AB the subject of the equation. Then you just plug in the value in the calculator. That's 80 sine 18, which is 24.7 meters is AB. Part B is asking us to find the height of the tower B. So height of the tower B, we already know the length of AB. We have the angle. So now BT is going to be the opposite in this triangle. So, but in this case, we will not use sine because we don't have the hypotenuse for the triangle TBA. But instead, we'll use tan theta equals to opposite over adjacent. Tan 25 equals to TB over 24.7 cross multiply to make TB the subject. Which gives us 11.5. Look at question 4. Question 4 says A, B, C, and D lie on a circle with center O, radius 8 centimeters. A, B, and C, D are tangents to a circle with center O, radius 4 centimeters. A, B, C, D is a rectangle. Calculate the distance of AE. So we know that the radius of the circle is 4. So this is 4, also 4. And the radius of the bigger circle is 8. So that means this entire distance is 8, which means that this is 4 This part is going to be 4. So that means find AE, we can use Pythagoras, where we can say 8 square equals to 4 square plus AE square. 64 equals to 16 plus AE square. 64 minus 16 equals to AE square. And then we take the square root of the result. So that gives us 6.9 centimeters. Yeah. In part B, it's asking us to calculate the shaded area. Okay. So for the shaded area, what we need to do is we need to find the area of the smaller circle, and then we need to find the area of the rectangle, and then subtract the two to find the shaded one. So area of circle would be pi r square. R for the smaller circle is 4. So pi times 4 square, which is 65, which equals to 50.3. Centimeters square. Area of rectangle. Area of rectangle is going to be the length times width. So if this is 4, this will also be 4. So the entire length of AD or BC is going to be 8 plus 4, 4 plus 4. So 8 times 5. Yeah. And then for AE, we found 6.9. So if this is 6.9, also this 6.9. So AB is going to be 6.9 times 2, which is 30.8. So we multiply 8 with 13.8, which gives us 110.4 centimeters square. So for the shaded area, we subtract the two. 110.4 minus 50.3 gives us 60.1 centimeter square. That is your answer. Look at question 5. Question 5 says that Antwerp is 78 kilometers due south of Rotterdam and 83 kilometers due east of Bruges, as shown in the diagram. We need to find the distance between Bruges and Rotterdam. So what we do is we need to apply Pythagoras in this case. X square equals to 83 square plus 78 square, which is basically 83 square is 6,809. 78 square is 6,084. Add the two, gives us 12,009. Take the square root on this side. That gives us 130.9 kilometers. Then part B says the bearing of Rotterdam from Bruges correct to the next degree to the nearest. So this is the angle that we need to find. So for us to find that angle, why not find this angle first, and then subtract that from this angle from 90 to get the bearing. So for this angle, we can easily apply tan. It's safer to go for like with the measurements that are already given in the question, because in case you did the first part wrong, you can still get the second part right if we use the existing. So tan theta equals to 78 over 83. Since we're trying to find the angle, so we always take inverse of the trig ratio. So when tan comes on the right hand side, it becomes tan inverse of 78 divided by 83. So the value of theta is going to be 43.2 degrees. Now, since we have to find the bearing, so for bearing, we're going to subtract 43.9. This is 46.8. So I'm going to write 46.8 as 046.8 degrees. The reason why I'm writing it like this is because the bearing has to be a 3-digit number. And the bearing is always measured from the north in the clockwise direction. So you need to be really careful about this thing. If you're not measuring it in the clockwise direction from the north, you're getting it wrong. If you're not writing it as a 3-digit number, you're again getting it. So your bearing is 46.8. That is your answer. And questions or confusions about any of these, just let me know in the comments below and I'll help you out.